Every single time you open a large language model to write code, it starts from absolute zero, again. The financial drag of this limitation is massive. A standard 10-person engineering team loses roughly $200,000 annually simply because developers spend nearly 20% of their day hunting down or re-explaining context the system has already forgotten. To compensate, developers have built elaborate manual workarounds. We write exhaustive system prompts or constantly paste repository readmes and architecture documents into the chat window before every session. But as project complexity grows, this manual injection method fails. The sheer volume of dependencies, client constraints, and recent code commits makes it impossible to load the full operational state into a prompt without severe friction. We are forcing highly paid engineers to act as unpaid data librarians for systems that are completely capable of maintaining this state autonomously. To fix this, we need to treat AI context the same way we treat capital. It should act as compound interest, accumulating value continuously. Every single code commit, every architectural pivot, and every client interaction serves as an automatic data deposit, making the model slightly more aware and useful than it was the day before. BizBrain OS is an engineered solution built specifically to solve this amnesia problem. Functionally, it is an open-source, local-first context layer. It operates entirely in the background of your existing coding environment as a plugin for Claude Code, silently organizing your work history. A stateful AI system shifts your operational baseline. It converts a stateless query tool into a compounding engineering partner that actually knows your business. The foundation of this system relies on its first architectural pillar, the data layer, which functions as the permanent brain. Instead of piping data into a proprietary cloud database, BizBrain relies entirely on a standard local directory tree. By restricting storage to Markdown and JSON formats, your entire operational brain avoids vendor lock-in and can be natively version controlled using Git. The system operates under strict security parameters. The codebase is open source under the AGPL 3.0 license. AGPL 3.0 is a strong copyleft license that requires any modified versions of the software to be shared openly. It features 0 external API calls from the plugin itself and contains no telemetry. By keeping the architecture entirely local and plaintext, you retain absolute data sovereignty and insulate your engineering workflow from vendor lock-in. However, maintaining a local knowledge base is useless if it requires the developer to manually write the updates. This timeline illustrates an active coding session. To automate data collection, BizBrain OS uses an event layer, a nervous system consisting of 3 invisible system hooks that fire autonomously. The first hook is SessionStart. It reads your local brain directory and injects total business context directly into the model before you type a single prompt. Next is the PostToolUse hook, which triggers automatically after every file read, write, or search operation. It captures real-time state changes and logs all system tool usage as exact timestamps, eliminating manual time tracking. Finally, the SessionEnd hook fires when you close the window, finalizing the session metadata and cleanly archiving the interaction log. Automated event hooks remove the human entirely from the loop of memory maintenance, ensuring AI context is perfectly synchronized with reality at all times. The third architectural pillar manages this inbound data. It is called the Brain Swarm, a multi-agent orchestration layer designed to process the event logs. This flowchart illustrates the data routing pipeline. Raw data from the PostToolUse hook is organized into a sequential event queue, feeding into the orchestrator agent. This centralized dispatcher analyzes and routes events to specialized sub-agents based on task complexity. The system utilizes smart model routing. Simple pattern matching tasks are routed to the highly efficient Haiku model, powering agents like the entity watchdog. Conversely, complex brain operations, like deducing architectural choices, are routed through the more powerful Sonnet model to the brain learner agent. This bifurcated routing architecture prevents computational waste. By matching the task to the correct model tier, it reduces agent operation costs by 40 to 60% without sacrificing capability. Crucially, to maintain data safety, these sub-agents are never permitted to write their findings directly to the primary file structure. Instead, they submit proposed structural changes to a staging area, which acts as a secure buffer zone. Inside this buffer, the orchestrator runs strict validation checks. It scans for conflicts, such as two agents attempting simultaneous file edits, and performs staleness checks to ensure the target document hasn't been modified since the proposal was drafted. Only fully validated changes are committed to the permanent directory. Every successful write generates a highly auditable daily changelog, recording exactly which agent made the change and why. The swarm architecture ensures the local brain scales autonomously, while strictly preventing rogue AI agents from silently corrupting the system's structural integrity. To see how this architecture performs in practice, let's look at a specific high-value use case: automated meeting transcription. This split screen compares the cloud approach with BizBrain OS. Standard SaaS tools charge roughly $18 a month and require uploading communications to external servers. BizBrain OS avoids the cloud entirely, routing system audio through local whisper models to generate transcripts natively on your machine. The system then applies local speaker diarization. Diarization is the process of partitioning an audio stream into segments based on speaker identity, accurately labeling who said what. Once transcribed, the raw text feeds into the entity watchdog agent, scanning the dialogue for client mentions. Finally, the pipeline autonomously extracts commitments, generating structured action item markdown files and injecting them into the correct project folder. This localized multi-agent pipeline proves that advanced orchestration can replace expensive, privacy-compromising SaaS subscriptions with free, superior local alternatives. Because operational needs vary, the architecture ships with 5 distinct role-based profiles, providing pre-configured setups tailored for developers, agency owners, and consultants right out of the box. While the core system operates entirely offline, it also supports an ecosystem of over 34 optional integrations, connecting your local brain to external platforms, ranging from GitHub to Go high level. These integrations are entirely non-locking. You choose exactly what to connect, and you can sever the API link at any time without breaking the functionality of your local brain. Despite the complexity of the underlying swarm orchestration, initializing this entire stateful architecture takes exactly 5 minutes. Deployment requires just 2 commands in your terminal: Claude plugin install BizBrain OS, followed by the / command, /brain setup. While the setup is nearly instantaneous, the operational advantage of a customized, stateful AI memory system will continue to compound over time.